Well, I'm glad you guys could make it. For the next few minutes, we're going to talk about access control across the .NET services. There's been a lot of talk at PDC about the .NET services and Windows Azure. And so we're going to focus in on how the .NET services and SQL Data Service use the access control service, because there's a common set of themes there. And I believe that those themes or those archetypes can be very applicable in your applications as you start to move to the cloud. My name is Justin Smith. I'm a program manager for the Access Control Service. So I've been living and breathing the Access Control Service for quite a while now. This service has changed my life, and I believe that it will change yours also if you embrace it. If you have any questions or comments as we move through this session, you can just stick your hand up and we can address it there. We've got a fairly small group, so it should be fine. If you have standing ovations or you have tips that you want to give me, then great, you can hold that to the end. And any roses or things like that that you throw, like a bullfight, you can hold that to the end as well. All right, great. So we've seen this slide several times, and I like to remind everyone at the beginning of a session really where we fit in. So this talk really focuses on the .NET Services block. It's the block right under the word Azure there. So it's really a set of higher level services that developers can use in their applications. They're not actually applications in and of themselves. Right? These are specifically designed for developers to use, a lot like the .NET framework is designed for developers to use. This talk also touches quite a bit on identity and security. And Microsoft, I believe, has a very solid story for identity and access control, both on-premise and in the cloud. And if you've seen Kim Cameron's and Vittorio's talk earlier this week, you heard quite a bit about this, right? So we have an offering for on-premise. We have the Geneva server that we're talking about here at this conference. We also have a Geneva framework, and I'll talk more about that as we walk through the talk. We've got a lot of stuff that we can offer on-premise, and we've got a great offering in the cloud. Now, I'm actually quite proud of this picture here. We've got a unified model, one identity model for both on-premise and off-premise. And the idea here is we don't want to control people's identities. We want to put the end users of applications in control of their own identities. We're simply offering some software and some services that make it easier for end users to be in control of their identities. So we'll talk about this as we move more through the talk. So I've broken this talk up into several different sections. One, we'll talk a little bit about the motivation behind the access control service. I won't focus too long there because I believe this has been covered in subsequent talks or previous talks. Then we'll do a real quick tour of the .NET services. So we'll do a whirlwind tour of the different service offerings and how you as developers can actually work with those services. And then we're going to focus on the service bus. We'll see how the service bus uses the access control service. Then we'll pivot to the workflow service. And then we'll pivot to SQL Data Service. So it's interesting to note that the .NET services and SQL Data Service are actually all using the access control service. Right? So we're actually using different services or using other services. So these are actually composable services. It's kind of a cool thing to take a look at. It actually creates a lot of challenges when we try to bootstrap services because they all kind of have to be online in a certain sequence. But that's a different story for a different time. And then last but not least, we'll talk about some usage patterns that we've learned as we've been using these services internally. And we'll talk about how you can apply these usage patterns in your applications. So I've got 4 demos set up for this talk and about 25-ish slides. So there should be quite a bit of content here. So if I have to summarize .NET services in just one slide, it's really the extension of our .NET capabilities to the cloud. So we took a look back several months, perhaps even a year and a half or so ago, and said, what are some of the things that we actually need to leverage in the cloud? What are some of the things that we need to build in the cloud to facilitate the move towards cloud computing? And there were 3 things that really jumped out at us. Actually, there were 4. One, obviously, was data. We've got to have a way to store and manage data out in the services world. And there were other teams at Microsoft that were already looking at this, right? So we said, all right, that one looks like it's pretty well taken care of. There's also the problem of connectivity. How do I connect to a service that happens to be behind a firewall or a NAT? That's actually a pretty hard problem to solve. If you look at trying to solve that on your own, you're going to take some really senior devs. You're going to take quite a bit of time. They're going to have to sit down and do some really hard coding, write some really core infrastructure code, and it's going to be a hard thing to maintain going forward. So if you actually want to connect to endpoints that are behind firewalls and NATs, you've got quite a job ahead of you. And that's the problem space that we meant the service bus to really address. It also does lots of other cool things about fan-out messaging and implementing, makes it easy to implement a pub-sub type messaging pattern, and there's all sorts of security options and really cool things that are in the service bus, right? And Clemens Vasters talked about that this morning. He's going to have another talk, I believe, tomorrow on the service bus. Then there's also the workflow service. Now, the workflow service allows you to run workflows reliably at scale. So one of the things you can do with the workflow service is orchestrate a series of service calls. You can also do XPath transformations on your messages, so you can do some basic content-based routing, and that capability will continue to improve in the future. So this definitely seemed like a problem that we needed to solve to facilitate the move towards really cloud-based computing. And then last but not least, to make all this work, we've got to have a common way to handle access to these different services. We've got to have a common way to deal with identities of users of these services and end applications. And how do we turn those identities into actually access rights for a particular application? So these were kind of the three core things that seemed like they would reduce the friction to moving towards cloud computing, right? So that's kind of what the .NET services are all about. It's about reducing friction to move to cloud computing. Now, all of those services I just listed have a common access control model. So they all basically use the same pattern for access control. Now, SQL data services can accept a token that's been issued by the access control service. There's actually two ways that you can authenticate with the SQL data service. The first is you can send it a username password as a basic auth header, so standard REST model there. You can also send it in a SOAP message as well. But you can also send a token that's been issued by the access control service. The service bus, same thing. The only way that, well, not quite the same way. The only way that you can access the service bus is if you present a token that's been issued by the access control service. So there's a pattern here. The workflow service, same deal. The way that you use the workflow service is by getting a token that's specifically issued for the access control service. And then this is one of my personal favorites. Have you guys seen the portals, the .NET Services portals in the labs as the hands just shoot up in the air? Okay. So the portals recursively use the access control service, right? So all of the portals that you'll use with the .NET Services to manage your access control account or set up workflows or manage workflow instances, they actually use the access control service as well. So we have one common model for these different services. And it's interesting to note that the service bus and the workflow service actually share code for token processing. So when you look in the source tree and you look at how tokens are actually managed, it's the same code base, right? Kind of a cool thing. Now here's how all of these services fit together. Now I like big diagrams to kind of draw people's attention into what the point is. Now, when you think of your app, could be an ordering app or it could be something like a Bluehoo type app. It could be practically any app. Imagine your app and imagine your customers. The idea, if you want to actually make money off your app or you want to sell your app or you just want to get a lot of users to your app is you got to figure out how to let your customers use your application. And if we don't want to create another store for usernames and passwords in our app, we've got to figure out how to reuse identities. So when you think of identity providers like Live Identity Service or an Active Directory domain user or a Tivoli user, really any identity provider, those identity providers are all about answering the question of who is the caller, right? We have a set of offerings that help application, or that are identity providers. We've got a live identity service, we've got Geneva Server, and obviously Active Directory. And in this talk, we're going to focus on how this rightmost part of the slide is taken care of. Right? So after you figure out who the caller is, you got to figure out what they're allowed to do in your application. Are they allowed to write data? Are they allowed to send a message to another partner service? Are they allowed to actually start up an orchestration? Right? These are all questions that your app has to actually answer. And if you've tried to do this before, they're actually not simple questions to answer. It can take quite a bit of time and quite a bit of code. And so when we see how this fits together, we hope, and it's our view, that the access control service is really an extension of your application that is running in the Microsoft data center. Right? Kind of like a component in .NET-based programming is something someone else can build, another party can build. This is a service that's running in the Microsoft data center that your app simply leverages. Same thing with the service bus and workflow and data. All right? The access control service has three core moving parts. First, there's a portal. The idea with the portal, it simply allows you to configure the service. So the portal's sole purpose in life is to configure your service account, your access control service account. There's also a client API that installs with the .NET Services SDK, and this gives you a programmatic way to do the things you would otherwise do on the portal. Right? So if you want to have a programmatic way to configure your service, we have an API for doing it. It's also important to note that this API is going to change quite a bit in the future. But it's there today, and we hope you kick the tires on that. And last but not least, there's obviously the service. This is really the core part of the access control service. It's a security token service, or an STS for short. And we'll talk more about how it actually works and the common interaction pattern with the service. But this service's sole point in life, or sole purpose in life, is to issue tokens. Right? So it issues SAML tokens, SAML security tokens. Right? And developers will interact with this service, in other words, request a token, with the Geneva framework. You can also use WCF and the .NET Framework 3.5. You can also use different Java stacks, like Sun's Metro 1.3. So we've embraced interoperability in the core of what we do when interacting with this service. So those are the moving parts to the access control service. And there's a common interaction pattern that we use in the access control service. And this is the same interaction pattern that the service bus uses, the workflow service uses, the portals use, and the data service use. Right? So imagine the three different nodes here on the slide. First, there's your application. We'll call that thing the relying party. And then imagine there's a customer, right, on the right-hand side. We'll call that the requester. And then up at the top, we've got your access control service account. And this is your STS, right? And we'll call this a virtual STS because of the way that we're actually hosting this service. So the first thing you need to do, your relying party will need to set up a trust with the access control service. And so this is done by way of a certificate exchange. So you actually send the access control service, either by way of the portal or by way of the API, a public key certificate. And this really defines how you want your tokens encrypted. Right? So tokens that are going to be issued for that relying party are going to be encrypted with the cert that you specify. Now let's say that you get a customer. So let's say you sell into Contoso Corp, for example. When you sell into Contoso Corp, if you want to give those users access to your relying party or your application, you should define some access control rules at the STS that will give those requesters access to your application. Very straightforward. You can do all sorts of things with configuring these different rules, as we'll see in just a minute. But the concept is you just define some roles or some rules for a customer. After those rules are set up, then the requester will send a message to the STS. And that message will contain in it some claims. Now, the formal format of this message is a WS Trust RST, or Request for a Security Token. And that will contain some claims in it. After the STS receives that message, It will then pull the claims out of the message and use those input claims to create or basically define or map a set of output claims. So we're defining rules in step number 1 in the STS. Those rules are used to create a set of outputs. Right? We just basically build a graph. We drive it to transitive closure. We come up with the output of that closure. And then we create a token and send it back to the requester. Now that token is encrypted with the certificate that you specified in 0, and it happens to be signed with the access control service certificate. And we'll talk more about that signing process in the next session. So I actually have a session right after this that drills into this in more detail. After the requester receives the token, we then send the token on to the relying party. After the relying party receives the message with the token, the relying party will then check the claims in the token and see if access is actually allowed. Right? So it's a 6-step process. And this gives you unbelievable flexibility when you embrace this process. It's given us the ability in the access control service team to actually create or support lots of different scenarios. When you think about how the service bus uses or its usage pattern, and you think that we've been able to work with this common interaction pattern, and then you think of a portal, you don't really get much different between the service bus and a portal. Yet this interaction pattern supports both of those types of scenarios. Now, central in the access control service is the way that we manage access control rules. So I want to introduce a few concepts into our discussion here. So when you have an access control service account, you have the ability to create access control rules. An access control rule consists of 2 things, an input claim and an output claim. You can actually have multiple input claims that will map to an output claim. Now, if you think of an application like SQL Data Services, if we were to just put all access control rules for all SQL Data Services user into one big bucket, it could become kind of hard to manage, right? Think of the service bus. It's kind of the same problem. We need to have a way to categorize or group, if you will, access control rules into manageable chunks. And so we have this notion of a scope. And a scope is a boundary around a set of access control rules. So when you create a rule, that rule must reside in exactly one scope. Rules are not inherited between scopes, so there's no notion of a rule executing in one scope and then by default executing in another scope. And we did that very intentionally. The idea is we want to make sure that when we process these rules, that we're not having to search a massive set of rules to figure out what to actually process to build our graph. We wanted to make it an order 1 lookup to be able to go to the right bucket, if you will, in the store, right? So along with the rules, your scope also contains different encryption preferences. You can also specify token lifetimes. You can set up different identity issuers. You've got several settings, like for custom claim types, that reside in a scope. So when you create a scope, you're really creating a set of access control rules along with the settings. Now, a scope happens to be named by a URI. That was very intentional. The idea is that URI, like foo.com or bar.com, is the address of your application. So one access control service account can service multiple applications, or it can service different parts of the same application, right? And it's driven by the URI. And we'll see how this works in just a few more minutes, right? So this is just a couple of concepts about how we handle rules, and it also flows into the way we actually store rules as well. So the common approach here, just sort of from if you're more of a word person than a picture person, same idea, right? Now, I want to drive home the fact that that model that was on the previous slide is exactly what the service bus is doing. It's exactly what the workflow service is doing. It's exactly what the portals are doing. It's exactly what SQL Data Services is doing. Right? So we've been able to work with lots of different teams with their own usage patterns in this common approach. So let's do a quick demo and see this in action. Any questions before I move on? Questions, comments, or personal attacks? Are those scopes hierarchical?
So yes, you have to get foo and bar. If I had something not foo and bar or pound back that, what does it encompass?
So we have a longest prefix match algorithm in the service itself. So if you have, let me go back to the PowerPoint slide here. All right. So if you have, instead of bar.com, foo.com/bar, for example, when you send a request for a security token into the STS, that request for a security token has a field that's called the applies to field. That applies to field will be a URI. We take the value of that applies to field, and we use that value to do a longest prefix match lookup on the right scope that will contain the rules. So if you don't have a scope defined that's foo.com/bar, we will select foo.com. Right? So you can always go deeper than what's defined in the scope, and the service bus does this quite often. You can always go deeper than what's defined there, but we'll always try to find the one that's lowest in the graph. Any other questions? Yes?
Is there anything today, like the access control service, that you can use on-premise, not on the cloud, that you can use in today's environment?
So we don't. So the question is there anything similar to the access control service that you can use on-premise? So it's interesting to note that our service is built with the Geneva framework. So the Geneva framework contains a DLL, and we use that DLL to build our SDS. So you could actually use that DLL to build something like this if you wanted to on-premise. Microsoft does not have an offering as of yet as a server product that's like the access control server, right? So we don't have definite plans for that going forward. Our vision for this is it makes a lot of sense in cloud computing, but we think it also could have applicability inside the enterprise. So it's something that we're thinking about. Any other questions? Nope? Cool. So let's see a demo. So I'm going to start with a fairly simple demo. And I hate to say it, but it's going to be so simple. It's add, subtract, multiply, divide. So it's a service. Right? Now, the trick here is not to show you how to build a really cool service. What I'm trying to show here is how we can take a service and actually use the access control service to gate the ability to send messages to it. Right? So I've got a service that's built here in Visual Studio. Now what I'd like to do is walk you through how to actually set up the access control service account from scratch so that an app can actually use the service. So I'm going to log into the portal, and when we log into the portal, we're actually logging in with Live ID. All right, so I click the little sign in button, and note that I'm using the live services here, so this is all for real. And as soon as we walk up to the portal, notice that we have the concept of a solution. And a solution maps to an account with the access control service, the ability to use the service bus, the ability to use the workflow service, and the ability to use SQL data services. So I'm going to walk up to Justin's demo account. So when we see Justin's demo account, you'll notice that there are links to interact with the different services. So SQL data services just has some getting started links because they don't yet have a portal of their own. The service bus gives you more links as well on how to use the service bus. And then the workflow service will actually give you a link into the workflow service management portal. And notice that we're gating access to the workflow service portal through the access control service. So I can go back. And then last but not least, there's the access control service link. So we're going to click there because that's the coolest of the cool. All the cool people use the access control service, by the way. And so we're presented with a page that is, how do we want to get started? Well, I like to keep things simple, so we'll start in basic mode. Everything you can do in basic mode, you can do in advanced mode. Advanced mode gives you more control over configuring your access control service account. That's all. So the first thing it asks us to do is to create an application. Now notice what we're doing here is creating a URI. Now what do you think that URI actually maps to? Knowing what we know about scopes, This will actually be a scope URI. This will actually create a scope in the access control service. So I happen to know that the URI for my service is localhost calculator service. So this is kind of cool because it's a cloud service that's interacting with a local service. So if I'm outside our network, I'm not going to be able to browse into the calculator service. I'd have to use the service bus for that. Right? So now I need to specify encryption preference. So I'm going to go to Browse. And I happen to have some certificates ready. I created these certificates with a little command file that used makecert. There's nothing special about them at all. They just have a public key and a private key. Now, what I'm uploading to the access control portal only has the public key. We don't ever want your private keys. You keep those to yourself and treat them as you would other private keys. Just give us the public key. All right?
So that cert does not have to be trusted up to a root key trust?
Nope. Well, so the relying party has to trust that cert on the level that it chooses. Right? So this is an important point to drive home. The certificate that we use to encrypt your tokens with can be any cert that you specify. In the back. Can you say that one more time?
How do you avoid namespace collisions with your URI? Do you have to prove that you own that domain?
Awesome question. I love that question. That's a great question. In fact, I'm going to give you a Zune for that question. But the trick is, you have to wear a wristband. So you can come up and get this now if you want. So this scope is actually local to your access control service account. Here you go. Congratulations. But you got to wear the wristband. Awesome. When you get an account at the access control service, like this one, my account name is Justin Demo Account. And so we reserve a namespace for you called accesscontrol.windows.net/JustinDemoAccount. All of the scopes that I set up there are local only to this access control service account. We really don't care if you set up a domain that doesn't have a trusted certificate with you, right? Because you're the only application that will be using that scope. Right? Now, other requesters can use it as well, but you're defining the encryption preference, so you'll be the only one that's able to actually decrypt the token. So we do not want to get in the business of trying to verify these URIs. And this model is smart enough in the way that we're reserving namespaces that it's just not a concern. Now, the greater question and the thing that comes up is, well, how do I actually control access to the domain, like to the Justin Demo account? In other words, could someone actually have an access control service account called Microsoft? Right? Now, that's an interesting question. Before we go to V1, this is something that we're going to have to think about. In our CTP mode right now, we don't actually have, like, it's basically a first come, first served basis. Right? But that's something that we know we're going to have to think through. All right, cool. Any other questions?
Have you thought about the plan of rolling CTP names into production?
Have we thought about data migration from CTP to production?
Of this particular account name. So
Yeah, so
CTP name under some name, will I still have that in production?
yeah, so the question is, if I get a CTP name now, is it going to exist in production? That's kind of up in the air right now, right? So we're trying to move towards a beta and then a beta into starting to close down towards V1. So these are all things that we're going to have to think through. So I go ahead and I specify the certificate. And now I'm going to go create some access control rules. Now, a rule can be really simple, and I'll zoom in on this because I know it's a little hard to see. Right? So I've got an input claim and an output claim. So for my input claim, I'm going to say Justin Demo Account. And that happens to be the owner of this access control service account. And I'm going to say calculator.add. Now, the little service that I've written requires for me to send a message into the add operation, you have to have an action claim where the value is calculator.add. All right? Really simple. So then I'm going to save this. Now I'm going to add another one, and we'll just do the subtract. And let's save it. So the question is, what are the other sort of claim types that we've got? So these are the ones that are there by default. So we've got a username, we've got a Windows Live ID, we've got an action claim, a group claim, right? So this can come from a directory service like Active Directory, Geneva Server, or Tivoli. And then emails, names, UPNs, and URIs. Now what's cool too is we give you the ability to define your own claim types. This is not an extensive list of all the claim types in the world, right? These are just kind of a starter set. All right. So now, I'm going to run the service. Now that I've set up the app and the access control service, it's asking me for my solution name so I know how to actually check the token. The service starts. Now let's start the client. It's asking me for my solution name and the password. I'm going to type that again. And if I've been living right, we'll see a couple of the operations succeeded, add and subtract, multiply and divide did not. All right, so I'm going to terminate the client. We're going to go back and add an access control rule. Now I'm going to keep the service running. I'm going to leave the service running as is. I'm going to go out to our live service, and I'm going to create another access control rule. So Justin demo account, I'm going to add the multiply. Add the multiply. All right. I can't help it. They just come out sometimes. All right. So now we're going to restart the client. Good question. And boom. So the reason we need the name and password is we've got to send some identity claims, some claims into the RST. Right? So we need to send some claims. Could be a Windows Live ID, could be a group claim, could be practically anything. Now, when you get a .NET Services account, we actually create some credentials for you. Right? So the credentials that we create for you are a username and password. We also give you the option of uploading a self-issued card space card, a V1 card space card. And we also give you the option to upload X509 certificates. Right? So you can create your own X509 certificate and use that certificate as essentially an identity claim, an identity credential. Now, we did this. We created our own credential store in the access control service simply as a way to bootstrap this service and help users use this. We have no aspirations whatsoever to become an identity provider. Right? So in the future, in future versions, that username, password, that X509 cert, and that self-issued SAML card, that self-issued card space card, are going away, and we're going to be using the live identity services as the credential store, as the identity provider. We just weren't able to get it done by PDC. Yeah. So it's simply a way to get up and running with the app. Now, if you want to go change those credentials, you can go to your solution and notice that there's solution credentials here. Right? So you can update those solution credentials for Justin demo account. And we'll see 3 that are available. So really what we've done is we've decoupled the notion of the account from the actual credentials. which is an interesting concept, right? Say again? So the question is, does this password have to be the same password that I use to get to the portal? The way that you get to the portal is with Windows Live ID. Right? So we keep a Windows Live ID handle, and when you log into the portal, you go through Windows Live ID. We don't ever want to know what that password is, right? This password is a password for your app to actually use, right? And this certificate is a credential for your app to actually use as it comes online, right? So that's kind of the access control service in a nutshell. I want to walk through real quickly how the service bus and the workflow service are actually using the access control service. Because the point here is I want to show how this model that we're using in these apps can hopefully apply to your apps. So when I go to the access control service portal, and we use advanced mode, it crapped out. So you probably don't want to see me debug that. I might if we have a little bit of time left at the end. So when I log back into the access control service portal, yeah, another question. So I think you're asking what kind of accounts can we use to get to the access control service? I see. So there's several ways that you can get to use the access control service. Remember that the access control service is meant for your app only. So if you're building the Foo app, you're going to have an access control service account. So the question really becomes not how do you get to the access control service account, it becomes what kind of claims can I send into the access control service so that I can drive rules that will allow my app, or that will give permission to use my app. So that's really the question I think that you're asking. And you can send a Windows Live ID in. You can send a group claim in. It could be a group from Active Directory. It could be a group claim from Tivoli, right? SiteMinder, right? There's a lot of different directories out in the industry that know how to do this. You can also send a username for a solution, username and password for another solution that's not the Foo access control service. We don't really see that having longevity. That's really just a way to bootstrap this service, right? So really we think the sweet spot for using this in the wild is going to be having an identity provider that's got the Geneva server in front of it or the Microsoft Services connector in front of it, and then using those identities to drive access control rules. So when we think about the service bus, remember that we've been saying the service bus and the workflow service use the access control service in pretty much the same way. And so when we log into the portal and we go into advanced mode, notice that we have access to work with the service bus permissions and the workflow permissions. And so what's really going on here is when I create a .NET Services account, the service bus creates a scope automatically for me. So in our provisioning process, we create a service bus scope, and the last URI segment of that scope happens to be the solution name. Right? The workflow service does something very similar. And then when we look inside this scope, right, we see that there's a couple of rules that are created as well. So this model of provisioning new accounts, creating a scope, and then adding rules automatically, that's just what the service bus is doing. Workflow service, it's exactly the same way. We'll talk more about this in a second. All right. So when a new account is provisioned, the provisioning agent creates a new scope. And the last URI segment, foobar or baz, in the diagram below, is actually the solution name. And so this requires uniqueness in solution names. right, which is already done at the front end of the provisioning process. And we also create a permission such that the solution that's being created, like Justin Demo account, has edit permissions on that scope. So there's an extra step here. If your access control service STS creates a scope, by default, no other access control STS owners can actually edit rules in that scope. But we do have the notion of being able to grant edit permissions for the rules in that scope to another account owner. So when we create a new account, our provisioning agent creates a scope, adds some access control rules into that scope, and then delegates, and I'm using that term loosely, delegates edit permissions for that scope to the new account holder. Right? So that's the model. So every account, this process happens. And so the service bus processes tokens in a common way as well. So the .NET Service Bus requires a token before you can actually work with the service bus. Now there's one case, and there's an unauthenticated access capability of the service bus. But in the end, for most of the features in the service bus, you got to present a token. And that token does a few things. One, it contains the namespace of the resource being accessed. So we know who's actually using the service bus, which account we should basically debit the usage against. Right? So it's just a counter now. It also has to contain some action claims. And there are two claims that the service bus understands. One is an action claim of listen. The other one is an action claim of send. And guess what they map to? If you're trying to listen on the service bus, trying to basically receive messages through the service bus, you got to have a listen claim. If you want to send a message into the service bus, you got to have a send claim. And we also define an encryption preference for how the service bus wants its tokens encrypted, right? And so we've talked a little bit about how those two rules are created. Now, the new account holder can modify these rules however they want. So they can add new rules, they can delete existing rules, they can create additional scopes. They've really got carte blanche with just a few limitations in that scope. For example, you can't change the encryption preference. That'd be pretty scary, right? You can't change the encryption preference. You can work within certain bounds of the token lifetime, etc. When you send an RST to the access control service for use in the to get a token to use the service bus, you've got a lot of different options on how you can do that. One, you can use the Geneva framework. Two, you can use WCF in the .NET Framework 3.5. Three, you can use different Java stacks. Right? Any WS Trust 1.3 aware stack can do this. And we actually have shipping versions in our SDK of how to use the Sun Metro 1.3 stack to do this. But we also ship WCF and .NET Framework 3.5 bindings that do the token acquisition for you. So in the .NET Services SDK, we ship a few additional bindings that automate this process of going and requesting a token and then sending that token onto the service bus. Right? So when you use the service bus and you use any one but a few of the options in the service bus, you'll actually be going and getting that data. Right? They're all accessible via standard WCF means, the transport client endpoint behavior. So there are several different knobs there, and I suggest you go to Clemens's talk to drive more into how those work. But the idea here is we wanted what ships in our SDK to follow and track very well with the way WCF behaves or the programming experience for WCF. Right? So we wanted you to be able to take what you know today in WCF and apply it to the cloud. That's the concept. All right, so let's see a little demo of the service bus in action. I have a dog. My dog's name is Allie. And I like to share photos of Allie. So we've got this little app that ships in our SDK called Simple Share. And to run Simple Share, you got to pass a few arguments, right? And what we're going to do is look at a directory, extract the contents of the directory, and make it available on a public HTTP endpoint, right? So we're actually taking local data and publishing it out to the internet. Now I'm going to press return here. Now remember, for me to actually get to use this capability, what do I've got to have? I've got to have a token, right? One of the ways that I can use that token one of the ways I can acquire the token is by presenting a card space card, right? So I've got a few cards that are associated with my solution. I'm going to send this one. Reminds me that that's the one I got to send for the alley demo, right? And pretty soon, the service will actually start listening for incoming messages, and there it is, right? So now I can go out to the web.
Does your code pop up that card space dialog?
My code does not pop up the card space dialog. What we were using was some standard bindings that ship with the .NET Services SDK to do that, right? So you're not actually interacting with the card space extensibility points there.
Because you chose the binding that came up.
Exactly. Exactly. Right? So now before I actually look at this picture of my dog, I've got to present some credentials as well. Right? So the sending of a message through the service bus is also protected by the access control service. And so I'm going to enter some credentials here. Okay, and we'll get to see a feed of the directory structure inside my little service. Right? So it's in the temp directory, and then there's a picture, and then there's my dog alley. Right? Pretty cool. Right? But that only worked for which user? This ACS PDC demo. How do I take this a step further? Because maybe I want to make that photo available to a different user. Like, how about the Justin demo account? And with the Justin demo account, I can get to this as well. Now, what drove this? The access control rule configuration for the service bus in this particular solution, ACS PDC demo, right? So this is driven by access control rules to give different participants the ability to send a message into the service bus and actually retrieve the data out. Pretty cool, right? And this sample ships with our SDK, all right? Very straightforward. And if you want to look at some of the code that's in this, the config is very straightforward, right? So the binding that we're using here is the web HTTP relay binding. That's a binding that ships with our SDK, right? And then we go ahead and create a service. We go ahead and add an endpoint to that service. This is all standard WCF behavior, right? Any questions, comments, personal attacks? Yep.
Would this work if the program service here running locally was implemented not on Microsoft platform?
So anytime you communicate with the service bus or the ACS, why are you winding your hand in the air, Nigel?
You should repeat the question, but I was watching the video.
Oh, I see. I didn't know if you had a tick or tennis elbow or something. All right, so the question is, can I do this with like native code? I think that was your question, right? Right. So how do you do this with a non-Microsoft toolkit? So you can interact with the service bus using anything that's WS Trust 1.3 aware, right? So there's several samples that ship in our SDK that show how to do this with the Sun's Java Metro stack 1.3. There's also some examples of how to do that. We'll have more and more examples of how to do this with like Ruby, for example, right? So it's not full ubiquity just yet, but we're working really hard on making sure that we have examples in lots of different stacks of how to integrate with the service bus. Now, we don't have full feature parity for what you can do on the Microsoft stack with what you can do with some of the other stacks, but we're working on trying to smooth that out as well. All right. So back to slides. The workflow service. Just like the service bus, when you create an account, a .NET Services account, you're given a namespace that will allow you to work with the workflow service as well. So we actually create two scopes when a new account is created. The first one has workflows HTTP in the URI segment. The other one has workflows in the URI segment. There's actually a little bit more that we do here to allow the portal to work on your behalf as well. But the concept is the same, that these different scopes give you the ability to work with the workflow service. So just like the service bus, the workflow service, for you to use it, requires a token, and that token is going to contain claims that the workflow service requires. Right? So there's an HTTP version, there's an HTTP powered scope, that's workflows HTTP, and there's also the SOAP endpoint, the workflows scope, right? And we just basically hang the solution name after workflows HTTP and workflows. The token processing is very similar to the way the service bus behaves, except the action claims are very different, right? So the action claims that the workflow service use are not listen and send. Instead, the claims that the workflow service requires are read, write, execute, and send. Right? So they've got a few more claims, and this list might actually expand in the future. The workflow service also specifies its own certificate for token encryption. Right? So when you receive a token for accessing the workflow service, that token is opaque to you, just like it is with the service bus. It's encrypted with the certificate that the workflow service has specified. And just like with the service bus, the workflow service grants edit permissions on the new account so that you can go work with that scope. You can go edit the rules in that scope. And you can even create subscopes if you like. Now there's a really interesting twist with the workflow service though. The workflow service is designed to let a workflow run for a long period of time. Now tokens have timeouts, right? So if I'm issued a token to work with, let's say, the service bus, let's say that token has a lifetime of 8 hours. If the workflow service is going to be sending messages to the service bus, and it's going to do it for longer than 8 hours, we've kind of got a problem. Because we've got to be able to get new or renewed tokens whenever our previously issued token expires. Right? So this actually created an interesting problem for the workflow service. And we solved it for the CTP using what I believe to be an intermediate step. So the way that we're solving this today is not going to be the way that we're solving it tomorrow. If you guys have seen anything with the Geneva framework, the Geneva framework has a pretty sophisticated delegation capability for allowing another party to access services on your behalf. There's an on behalf of semantic, and there's also an acting as semantic that's available in the Geneva framework. We're moving towards using those in the future. What we've got today is the concept of an authentication token. So when you create an instance of a workflow, you will actually request an authentication token for the workflow service to hang on to on your behalf. So the workflow service will hold on to an authentication token. And when the workflow service needs to send a message to the service bus or do other work, it will then go exchange that authentication token for a service bus token. So that's the concept there. Now, this is not a model that we're really going to propagate for too much longer in the future. This is something that we want to be able to scope down. So instead of just being an authentication token, we need it to be scoped to a particular set of resources. Right? And so that's an area that we're still working on. Right? So I'd like to show you kind of how this behaves today. So under my account in the portal, I can go back into the workflow portal, and we're going to create a workflow type, and then we're actually going to start it. So I'm going to go to the workflow service portal, and I've already got some XAML ready to go. This is the standard Watchdog application. And so I'm going to add a type, and I'm going to give it a name, Justin Watchdog 3. I know I'm going to create some rules. Sort of Julia Child style. Now this workflow is really, really simple, right? The interesting thing about this workflow is it's sending messages to the service bus. So right down here, we've got a couple of service bus send activities, right? So all these things are going to do is try to send a message through the service bus, okay? Which means we now have this problem of what do we do if our tokens expire, right? So this simple workflow illustrates how we're handling these authentication tokens today, all right? So now what I need to be able to do is create an instance of this workflow. So I'm going to click the Manage Instances button, and I'm going to create an instance. All right. So it assigns for me an instance name. Now before this thing starts up, I'm going to start Fiddler, because I actually want to capture the traffic of what's going on between the browser and the service. All right, so I'm going to say Next. I've got a certificate error because I've just attached Fiddler. It's not because our services are defunct or anything like that, right? So I'm going to continue to the website. And I'm going to be prompted for credentials. Now, the reason I'm prompted for credentials is the workflow service needs to get an authentication token so that it can access the service bus on my behalf in the future. And we don't want the service bus to actually have the raw credentials. So we don't want to store a username and password with the service bus's AML and rules, for example. That would be a problem. So instead, we ask for an authentication token. And again, all of these certificate errors are purely a function of Fiddler, nothing else. And so I'm going to stop capturing traffic, and we'll see that I've got a created instance. So I can go ahead and start that instance if I want. But instead, I want to show you the traffic. And so when we look at one of the interactions, we see that we've actually got something that looks like a hash. It's after that token equals. That's kind of a giveaway, right? Now, this is not actually a token. It's a handle to a token. It's actually a hash for one of these authentication tokens, right? So the workflow service redirects the user to the access control service system, asks them to enter their credentials, and then returns a hash back to the caller, which happens to be the workflow service portal. The workflow service portal can then exchange that token, that hash, if you will, for a full-on token with a different request to the access control service account, right? So I wanted to kind of demystify why we're prompting the user for creating a workflow instance for their username and password or an info card or a certificate, right? And the reason is the workflow service has to be able to do this work on its own for a long period of time. And again, this is going to change. We're going to scope this behavior down so that this token only grants access to some resources. Any questions, comments? Personal attacks? None? All right. Cool. SDS, SQL Data Service. So as I mentioned earlier, SQL Data Service accepts a token, and it can also accept a username password. So SDS has its own credential store right now. It has its own username and password credential store. And you can send that username and password directly to SDS, to their front ends, and they will authenticate a caller using standard REST models. It's just in the www authenticate header, right? It will verify the username and password and grant access to create authorities, create containers, and create entities accordingly. But they also have this other capability to where you can request a token from the access control service to create an authority, retrieve an authority, create a container or entity, right? So there's actually two authentication capabilities in the SQL Data Service. Now, over time, this will migrate and merge, but for now, we've got these two different capabilities. So every time you create a .NET Services account, just like you do with the service bus and just like you do with the workflow service, the provisioning process does some work in the access control service. So SDS actually has an account with the access control service, right? And when a new account is provisioned, we don't actually create a unique scope for that account. Instead, what we do is we go to an existing scope and we add a rule. And that rule is username, whatever the username happens to be, Justin Demo Account, foobar, or Baz, as an input claim. And then the output claim is a UPN claim. And the UPN claim has the structure of solution name at mssds.com. So internally, the SDS infrastructure can verify that the creator of a container or the creator of an entity is Joe at mssds.com, regardless if they come through the REST head or their basic auth SOAP head or with an ACS token. Right? So on every entity that you create and every container that you create in SDS, they hang on to a creator field. And that creator field is a UPN claim. Right? So this gives you today the ability to access SDS through a couple different ways. Right? We'll be working on this integration in the future. Has anyone in here worked with SDS? A couple guys on my team. Okay. It's actually a really slick service. So we use SDS internally. So the way that we store scopes and the way that we store rules and encryption preferences and all that stuff is SDS. Right? So we've got services using other services inside, this Microsoft Azure initiative, which is really cool. Right? And to be honest with you, I was hesitant about how this would go in the last milestone actually using SDS, and it went really well. We've been really happy with the way it's progressed. So that's real tricky to bootstrap. Yeah, it was a thing to try to sort of weigh our options there of how we're gonna view that. All right, so let's see a demo. So SDS has this tool called st.exe. And st.exe is simply a .NET assembly with a config file that sits behind it that allows you to create authorities, containers, and entities in SDS. Now, before you actually interact with your data store, you've got to present credentials, right? One way you can do it is just by presenting your username and password in a www authenticate header, right? Standard model there. You could also wrap it in a SOAP message. However, you can also get a token from the access control service account, right? From the access control service. So I've kind of gone ahead and done that, and some of the command arguments to doing this are really simple. So stcreate /infocard, meaning I want to use a self-issued card space card that's associated with my solution as an identity credential, and I also want to use SOAP. I want to go to Justin's authority 55. That's a thing in SDS. I want to go to that authority, and I want to create a container. The container name is container 100. All right, so instead of container 100, I'm going to say 101 because I've already created 100. I'm going to send my card space card. And while that is actually doing the update, it's already updated. All right, so that worked. So I should have a container 101 in SDS. So I'm going to browse to that as well. I'm going to browse to that same resource. Now, what's going to be interesting here is I'm prompted for my basic auth credentials. So I'm actually, the way I created this container is with my ACS token. So I went out and I acquired an ACS token through st.exe. And here, when we look at it through the browser, I'm trying to use my REST credentials, right? The credentials that are actually stored in SDS. So I say OK, and there's container 101. Real simple. Real simple. They have WSDL, so SDS has WSDL, so you can literally add service reference this. If you guys are used to WCF, you literally add service reference, point to their WSDL file, and you can get a proxy that will do this for you automatically. And in their SOAP class, they've got things like entity, container, those sort of things already built for you, right? So it's really simple and easy to use. Actually, in this milestone, it was a big deal to get that add service reference working, right? But we got it there, and so we're set and ready to go. Any questions about SDS? Nope? Okay. Moving on. Usage pattern. So we've seen how the service bus, the workflow service, and SDS all use the access control service. And I'm hoping that you're starting to see a few patterns and how the interaction can be, right? So the specifics are actually going to be driven by your application. But I feel that the access control service can actually fit in a lot of different scenarios, right? So here's a couple of common patterns that kind of track with what we've been saying. So one is you can use a service account to access the .NET services. You can use those solution credentials to access the .NET services. So imagine you've got an app, and that app has already done its authentication and authorization for its users. So let's say it's an app that's been around for 10 years, right? If that app's been around for 10 years, you've probably got inside the app a way to do authentication and authorization, right? If you want to take advantage of some of these services like the service bus, or you want to take advantage of the workflow service, or you want to take advantage of SDS, you can use your solution credentials in the back end of your application to go ahead and use those services, right? So you can handle all of the user authentication or other system authentication with the mechanisms that you've already got. Now, as I mentioned previously, these solution credentials are going to change from being stored with the access control service, and they're going to move out into live identity services, right? But the concept is still viable. Another option, if you're trying to federate with different users, and this is the one that we think is the real sweet spot. So let's say you're a software vendor, right? You've got this great idea. Let's say you're 5 guys in a garage or 10 guys in a garage, 10 people to be politically correct in a garage. Could be a big garage, right? You've got a really cool idea, and you want to be able to sell your application into businesses. One of the things that you're going to have to overcome to pull that off is you're going to have to be able to integrate with a company's existing identity provider. You can't walk into Microsoft and try to sell software unless you can integrate with Microsoft's Active Directory. Full stop, right? So when as employees, when we do our corporate expense reports, we don't ever have to enter our usernames and passwords when we're inside the organizational boundary, when we're inside the LAN. And that's because those companies have actually integrated with our Active Directory, right? So what we're doing here is through the access control service, we give you the ability with our other offerings inside of Microsoft to handle all these different types of identities. So you can have a set of rules, and those rules can say, if you're in Group Manager from Contoso or Group Manager from Microsoft, then you are able to call like the calculator add example. It's that easy, right? My subsequent talk and the talk right after this one, I'll actually show you how that works. So I'll drill into that specific scenario in a lot more detail. So approach 2 is the one that we think, this latter one that I described, is the one that I think is going to have legs in the future. I think that's the one where you'll get a lot of traction and you'll see a lot of the value in the access control service. Now it's also introduces an idea of, well, if I'm onboarding customers, let's say I'm in that second category, and I'm trying to federate with lots of different companies and trying to handle lots of different identities, and I want it to be as frictionless as possible, how do I manage scopes and rules? How do I actually manage this? Well, there's 2 different approaches that you can take. One is you can define scopes based on sets of customers and actually update rules accordingly, kind of like the service bus does. So you can create essentially a namespace for your different customers and add scopes and rules into this structured set of scopes, right? So that's one option. Now, not all applications are going to have that flexibility, right? So maybe you've just got one endpoint address, like a portal. A portal is a great example of this. You've got one address. You want at that one address to be able to handle lots of different identities. So a way that you can handle that there is dumping a bunch of rules into a scope, right? Now, both of those are viable, but we've got our API that allows you to do that programmatically, regardless of the approach that you take. whether it's a bunch of scopes and rules that are partitioned into scopes or a big scope with a lot of rules, right? You can handle that automatically and programmatically from our client API. Now, as it turns out, in the CTP offering that we've got today, we do have quotas in place on the number of rules that you can have in a scope, right? So for the accounts that we're creating for customers, you can only create 100 rules in one scope. Now, as we move out towards V1, that quota is going to go up, and we'll have different scope types. Right? This is our current thinking. Our current thinking is we'll have a set of different scope types that will allow you to dump thousands and thousands and thousands of rules into a scope. But there'll be some constraints around that, and we're still doing some thinking about how that'll be offered. But we've got something similar today for SQL Data Services and the portal. That's how we're managing n number of rules in a scope. Right? So it's going to take us some time before we can offer that into the general account base. So there's a lot of different options, and I strongly encourage you to take a look at this service, kick the tires, use the SDK, walk through the different samples that are in there, and most importantly, we'd love to get your feedback. As a little history note, this team was founded on a couple of core principles. One of them is we like to do short development milestones. So David Wertendijk is one of the founders here. He's in the room. John Shuchuk and Dennis Pellerinos are the other guys that started this team. One of the core foundations is we like to have short milestones, and what we do in those milestones is driven off of largely customer feedback. So a lot of the features that you see today are driven off of feedback from internal customers inside of Microsoft and also external feedback. Right, so we like to have these short milestones that are driven off of feedback, and that doesn't stop now that we're in CTP mode under Windows Azure and Azure services. Right? We require that feedback for us to make sure that we're offering the right thing to the community. So I encourage you to go to azure.com, check out the Azure services, take a look at the Access Control Service, and really let us know what you think about Access Control, Service Bus, Workflow, and SDS. We really do take it seriously. Now, last but not least, we also take the feedback on the session very seriously. So I'd love to know what you guys thought about the session, so fill out the evals. And thank you guys very much for attending. Even though it was a change in session, I really appreciate it. And I hope you guys pick something up. So thanks a lot, and have a great day. Questions? Yes? In the first application where I make the identity claim? So the first application, are you talking about the service? The client. So in the code, we've got a auto-gen proxy called calculator client. And then in the standard WCF parlance or standard WCF model, we update the client credentials to a username and password. And those get shipped or treated as identity claims for token issuance. So that's how it's done. So the question is calculator client auto-generated? So calculator client is auto-generated, but I had to write this code. So I wrote that code, and then I've got methods here called read solution name and read password. Exactly. So when I type that in, that's where the claims are coming from. You can put this in config. You can put a certificate in config. You can also prompt for a card space card. And we'll show that in the next talk that starts at 4:45. So right now, it would not accept a certificate as an identity claim. So when I go to app.config for the client, the way that you can tell that is the URI that we're actually communicating with has username for certificate. So when you create an access control service account, you get a set of endpoints that you can send RSTs to, and those endpoints vary based on the type of claim that you're sending in. So there's one for usernames and passwords. There's one for X509 certificates. There's one for self-issued SAML cards. There's another one for just a SAML token that's been issued from like Geneva server, or a SAML token, a token that's been issued from the Federation Gateway. All right, so we just have a set of these endpoints. I think there's 6, right? And you just target your RST to the right endpoint. Now, over time, as we start to move forward, we'll start to consolidate those because we've probably got too many to choose from. So we actually want to build more intelligent endpoints so that you can just send data and then we can determine based on the contents of the RST what to do with it. Yep. Any other questions? Yes?
Yeah, if I want to pass other authorization data into an application, such as a quota or a limit, some value, is that just another claim without noise?
So the question is, if I want to send other authorization data in as input claims, how does that work? How does that work?
Input to my application, but not input to the authorization server. So I got an account Joe. When Joe logs in, I want the auth server to say, this is Joe, and by the way, he has a limit of 15 thing he can do in the graph.
I see. So when you send a message to a relying party, I think what you're saying is, in addition to the authorization token that comes from the access control service, how do I send additional data?
Sure.
Okay. So when you send a token to the relying party, you can also send a payload that is of your making. So the requester defines a payload and sends it to the relying party. It doesn't sound like it's quite what you're asking for, because there's also data that's based on the relying party quotas.
I'm looking to have some of that payload be configured along with those rules.
I see. So we do have a rule type that allows you to copy input values. So let's say you get data from another STS. So if you send data into the access control service that's been issued by another STS, we can countersign that data and push it into the authorization token. David? Yeah. So you can define a rule that is a quota. Yeah.
Because the idea is to put those auth decisions big external, right?
Yeah. Yeah. Other questions? So I'm being told that that's time. Well, guys, thank you very much. Enjoy the rest of PDC.